So we'll begin with question 24. Till question 23, I guess I've shared the video recording with you. So 24 onwards, take question 24, PHMGBr plus CH3, C triple bond N, hydrolysis. What's the popular choice?
Sir, option C.
Yes, please.
Sir, option C.
Option C, Calcutta. Naturally, option C, Calcutta would look all right. This is what we'll get. I think I've done this with you. This would migrate. PH minus would come here, and double bond N in GBr will become double bond O. 25. 25 looks like C double bond.
Sir, option A.
O C2H5. Yes, please. What's the popular option?
Option A. A apple.
CH3 and GBr with excess H3O plus. So naturally, this would give you finally an alcohol like this. I think you're all there with me. This will react with 3 moles of this. Excess মানে কি এটা this will react with 3 moles of this. আগে এটা CH3 মাইনাস হয়ে যাচ্ছে, তারপর এখানে একটা CH3 মাইনাস চলে আসবে। So one CH3 minus would make it look like CH3 C double bond O CH3 and another, I'm sorry, 2 moles. No, 3 moles. 1 mole would make it look like an ester, another mole would make it look like a ketone, yes or no? And the third mole would make it a 3DB alcohol, yes or no? Bachelo, हाँ ना बोलो.
Yes, sir.
So this is also obtained by B and C as well. So this is B, this is C, yes or no? So option D would look right. Option D would look right, which is both B and C. Yes or no?
Yes.
की भूल भाल also. I want you to look at question 26 now.
Sir, option A.
बेटा मैं पढ़ा रहा हूँ, क्लास के बाद बात करूँ। हाँ मेरा बच्चा, बोल मेरा बच्चा। हाँ बोलो। Grignard reagent will become a hydrocarbon. Wait. हाँ मैं सुन रहा हूँ बेटा, बोल बोल मैं सुन पर बोल 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 मैं सुन रहा हूँ, बोल। म्यूट हो गया। हाँ बेटा बोलो। हम वो फोन कर रहे थे, हम तो क्लास में। ऑल गुड। हाँ मेरा बच्चा बोल, बोल ना बेटा। बेटा वीडियो कॉल नहीं कर पाएंगे, अभी क्लास में हम। बोल बोलो। मैं क्लास खत्म कर लूँ फिर फोन करूँ बेटा। All right, tell me what is the popular answer for 27?
Sir, option C.
Who will tell me? Yes, please. 27. Well, A would look like compound A would look like the corresponding Grignard, and this Grignard would naturally attack it in a manner. See, this would attack it like minus. This minus would naturally ये ऊपर से लगा है, so this would come from behind. This would come from behind. ये तो attack करेगा, ये उठ के यहाँ पर आ जाएगा. Yes or no? बच्चे लोग हाँ ना बोलो. तो ये ऊपर में ही रहेगा, ये OH ऊपर में ही रहेगा. एंड नेचुरली ये उसी का ये अगर इस कार्बन पर आ गया OH ऊपर में, तो उसके बगल वाला कार्बन पर यू विल वांट टू मेक इट फ्रॉम बिलो. Yes or no? Which is option A, I believe. 27 is all happy with A? 27 is all happy with A?
Yes, sir.
28 methyl benzoate. Methyl benzoate with 2CH3 MgBr and hydrolysis. So this is methyl benzoate 1, 2, 3, 4 with 2CH3 MgBr with 2CH3 MgBr. Naturally एक मिथाइल लगेगा, एक और मिथाइल लगेगा. So it's going to become like this: एक मिथाइल, एक और मिथाइल, and OH here. So what's the right option? 28. Come on, tell me. Option B, Bombay looks all right. Option B, Bombay looks all right. We'll talk about 29 then. How many moles of Grignard will be consumed when it reacts with a given compound? Number of moles of Grignard. 29 number of moles of Grignard. Yes, what's the popular answer? So number of moles of Grignard, which will be consumed with. Now this is the compound at hand. So this is OH, this is FH, this is CHO. You have a C triple bond in here, a C double bond OCl, and a C double bond O ethyl. Come on, what's the common answer? 8. 8 indeed is the right answer. 8 indeed is the right answer, which is option B. And I think you all are getting it right. यहाँ पे 2 मोल रिएक्ट करेगा, यहाँ पर 2 मोल रिएक्ट करेगा. 2 to 4, 8 5, 8 6, और ये हाइड्रोजन है, हाइड्रोजन. ये दो हाइड्रोजन would again waste to Grignard. 2 to 4, 5, 6, 7, 8 is the right answer. 30. How many carbonyls with the formulate C5H10O will react with Grignard, any Grignard, say in this case PHMGBr, to give a racemic mixture. Again, what's the common answer here? So yet again, I guess I told you, a carbonyl with Grignard, the RMGBr and hydrolysis would give you this chiral. Obviously, if these two are different, they need to be different. Yes or no? These two need to be different, and obviously different from R as well. Then only it will be chiral. Yes or no? So we'll go about drawing all carbonyls with the formula C5H10O. You would have wanted to give it a try by now. I'll want to hear what is the common answer. Please go ahead. So C5H10O, say let's draw aldehydes first. 1, 2, 3, 4, 5. This is pentanol. 1, 2, 3, 4, 5. फिर 4 CHO में एक ब्रांचिंग मैं यहाँ पर रखूंगा, एक ब्रांचिंग थोड़ा दूर रखूंगा. Yes or no? और 3 कार्बन का प्रोपानॉल में I think this is the only possibility. So I think I can draw 4 aldehydes. With 5 carbon, I can draw 4 aldehydes. And the number of ketone molecules I can draw is 1, 2, 3, 4, 5, which is pentane 2-on, pentane 3-on, and I think this is the only possibility with a branching on this carbon. So I could draw 3 ketones and 4 aldehydes, where naturally this is going to stick to A and B different. This is going to have the two different. This will have the two different. This will have the two different. So all the 4 aldehydes will give you a racemic compound. In this case also, this A and B are different. Now this is symmetrical. This is symmetrical. This is symmetrical. I think you're understanding me. Pentane 3-one would not give you a racemic mixture because it would not give you an alcohol which is chiral in the very first place. यहाँ पे alcohol chiral होगा ही नहीं. So ruling out pentane 3-one, I'll have 1, 2, 3, 4, 5, 6, and the count of carbonyls giving racemic mixture. C, Calcutta seems to be the right answer. We'll move on 31. Again, something I've done in details with you. 31 reads ClCOOET will react with X moles of RMgX. You have to find X. It gives you a 3-degree alcohol finally. So it could be ClCOOET, it could be C double bond OOET on both the sides. It could be C double bond OClCl. In all the cases, this X would be equal to 3 because 1 mole would remove one group, another mole will remove another group, 2 cases of nucleophilic acyl substitution, and finally it will add to this carbon. मतलब OET से भी better leaving group होता है Cl minus. Halides are the best leaving groups because they are the weakest bases and come from the strongest acids. HCl सबसे strong होगा. 32. So 31, 3 is the right answer. I think you're all getting me. People online will want to respond.
Yes, sir.
32 H एसिडिक हाइड्रोजन है, यहाँ पर COOAT है. यहाँ पर कितना मोल लगेगा? यहाँ पर कितना मोल लगेगा? हाँ, 3. 2 यहाँ लगेगा और ये भी तो लगेगा. ये भी तो लगेगा. वो अलग बात है कि ये OMDBR फिर OH बन जाएगा. ये OMDBR फिर OH बन जाएगा. So because in the product they give you OH, because in the product it's giving you OH, this should not mislead you. I hope you're getting me. This would not mislead you because 1 mole PHMTBr with this would form benzene, और ये जो OMDBR बनता है तो हाइड्रोलाइज्ड OH ही बन जाएगा. ये सुनो, 1 मोल का वेस्ट हो गई. You getting me? ये वापस वो OH बन रहा है, इसका मतलब ये थोड़ी है कि it's not reacting with Grignard. Grignard के साथ में वो बेंजीन बना देगा OMDBR again. When you're hydrolyzing this will also get hydrolyzed to OMDBR, will become OH again, but in the process it will kill or destroy 1 mole of Grignard here as well. So the answer will be 3. The answer will be 3. B, C is the right answer here as well. We'll want to move on. 33. Question 33. Which Grignard is not possible? All of these. Option D is right because in Grignard A you have an SS group, in Grignard B you have an OH group, in Grignard C you have NH2. So naturally all contain acidic hydrogen and Grignard formation is not possible here. 34. So this comprises column 1 and column 2 is about PHCH2OH, Q is PHCH2OH, R is this triphenyl methanol, and S is again a 3-degree alcohol of this kind. So A and B and C and D, they're all reacting with excess phenyl magnesium bromide. Come on, tell me. So A would match to R because 3 moles of PHMGBr, 3 moles of PHMGBr, would get attached to the left, to the right, and finally all the three would be pH, all the three would be pH. So A would be matching with R. A would match with R. A would match to R. B, naturally here it will require 2 moles of PHMGBr, and in the process, this pH would come to the left, this pH would come to the right, ये निकलेगा, and ये benzaldehyde would react with 1 mole, and this will give you a 2-degree alcohol. So it will be pH, CH, OH, pH. 2 pH रहेगा, क्यों है ना? Third one would react with only 1 mole of Grignard, will react with only 1 mole of Grignard, and it will give you a 1-degree alcohol having 1 more carbon, which is P, and D would react with 2 moles of Grignard. 2 pH लग जाएगा, पहले एक निकलेगा, दूसरा करके एक और pH लग जाएगा, 3-degree alcohol बनेगा. I think there is no confusion here. 35. Now in 35, column 1 comprises of PHMGBr plus something becoming a 1-degree alcohol, then PHMGBr with something becoming a 2-degree alcohol, then PHMGBr with something becoming a 3-degree alcohol, and then PHMGBr with something forming benzene. So the last one, would require an acidic hydrogen. Column 2 would contain this compound, which is obviously having an acidic hydrogen. Q is a ketone, R is an aldehyde, F is formaldehyde. Come on, quickly tell me. So A, and for A, the compound A is formaldehyde. B, and the compound B is R, which is any aldehyde. C, compound C is Q, which is a ketone, and D, compound D is certainly P, because this calls for an acidic hydrogen which is present in the active methyl group, है ना? तो यहाँ का जो हाइड्रोजन है, ये हाइड्रोजन निकल जाएगा, it will convert PHMGBr to benzene. 36. So in 36, it's PHMGBr, it's PHMGBr reacting with a dicarbonate, a carbonate, and then a compound containing a ketone and OH, and then this ketone and a compound having say 2 OH groups and a carbonate. Fair enough? And in two, you have number of moles of PHMGBr used. Number of moles of PHMGBr used, which is written as 1, 2, 3, and 4. So go ahead. Here A reacting with this. How many moles? 3 moles. So A would match with R, which is 3 moles. B naturally एक वहां जाके अटैक करेगा, एक यहाँ पर अटैक करेगा. This would mean Q, which is 2 moles. C naturally this will react with 1 mole only. And D, how on earth? वही तो बाकी है, क्या होता है? कौन बोल रहा है वही तो बाकी है? बोलिए, वही तो बाकी है. So you can't be so naive, you know, कि वही जो बाकी है उसी के साथ जाओगे. D would be R again. Yes or no? वही तो बाकी है. 37, 38, 39. Let's move on. 37, 38, 39. बच्चे लोग. So 37 is say about benzene ring, and we did it incidentally today itself. Although you know it from the times of KMNO4 Friedel-Crafts reaction. So sequence of reactions which are all using familiar reagents. Now A certainly. Come on, keep on guessing. Guessing, can you know the isopropyl benzene is you mean B is now any alkyl benzene, methyl, ethyl, propyl, isopropyl. I told you as long as there is at least one alpha hydrogen. यहाँ पर एक alpha hydrogen है. एक alpha hydrogen होने से they'll all get oxidized to the same compound which is benzoic acid. Yes, you remember that. People online, हाँ ना बोलते रहो. And naturally, this subjected to pH MgBr 2 moles were converted to acidic alcohol. Now this is option A, I believe. 37, I think I'm being understood. 38, what's the common answer? 38, what's the common answer? 38, what's the common answer? Sorry? D ही है, D ही है. 38. अस्मित बुझते पाच्छो? Hydrocortisone oxidation, তারপরে pH MgBr hydrolysis is giving you A. And this with OMDM is with Grignard giving you B, A and Br. Now, naturally, the product of hydrocortisone oxidation, would be an anti-amar alcohol, which will tautomerize to an aldehyde, and naturally, with pH MgBr, it will give you a 2-degree alcohol, which will look like this. And OMDM would give you a Markovnikov. This is anti-amar. So an anti-amar terminal alcohol will tautomerize. This will tautomerize to an aldehyde, and a Markovnikov rule non-terminal enol will tautomerize to a ketone. And with a ketone, you'll naturally get a 3-degree alcohol. Now they both happen to be isomers, but constitutional isomers could be the right answer here. They are related as constitutional isomers. Yes or no? We'll move on to 39. Hope you're understanding me. 39, what's the popular answer? What's the common answer? Well, in 39, you begin with a compound with a pi bond, and that is a per acid. This is a per acid. You know, MCPBA is metachloroperoxobenzoic acid. So basically, this is a popular choice of COOH, peroxo acid. Metachloroperoxobenzoic acid. So basically, what it will call is lose hydrogen, and in the process form a cyclic ether. It will form a cyclic ether here. Now this with PHMGBr on hydrolysis is supposed to give me an attack in lines with an SN2 kind of mechanism, where certainly if I have this pH attacking from above, I'll have this OH below, or if this pH is below, I'll have this OH above. Yes or no? So incidentally, both option A and C look identical here. Both option A and C look identical here. है ना? बच्चे लोग हाँ ना बोलो. ऑप्शन ए वाला दिख रहा है ये. सी बी में incidentally this is a writing error. I keep on saying at times I make mistakes, so I have made A and C options identical. You think A or C both will be correct? There could very well be an option like this. I hope you're understanding me. That's the basic criteria of an SN2 happening over a three-membered intermediate. A three-membered intermediate will always lead to an anti-addition. तो एक नीचे से रहेगा तो एक ऊपर से रहेगा, pH ऊपर से आएगा तो नीचे चला जाएगा. और ये इसका स्टीरियोकेमिस्ट्री है. रिजियोकेमिस्ट्री के रिजियोकेमिस्ट्री है. pH minus will always attack the carbon which is less crowded. So it's both regiospecific and stereospecific in that regard. We'll want to move on. बच्चे लोग हाँ ना बोलो. हाई टाइम. अब ये सब खुद प्रैक्टिस करो. अब ये सब खुद प्रैक्टिस करना चाहिए. ये सब खुद बनना चाहिए. 40. The moment you see a diene, and it's a very, very popular common question by now, you'll want to know that 1,4 addition is the major product here. So in 1,4 addition, this pi bond would shift here, the bromine would come here. I'm not explaining 1,4 addition. I think that for you to understand, I could very well just tell you that the resonating structure would be hydrogen coming here, and the positive would finally move here. तो हाइड्रोजन यहाँ पर ऐड होता है, ब्रोमीन यहाँ पर ऐड होता है, इसलिए इसको हम लोग 1,4 एडिशन बोलते हैं. और 1,4 एडिशन के बाद the rest is simple. Magnesium ether would convert it to the corresponding Grignard, and carbon dioxide water would lead to carboxylation, and the final product would be an acid, which is given as option B, Bombay. I think you don't have any complaints with 40. 41, we'll want to move on. 41. Question 41 is about an anti-MR addition to begin with, followed by a very simple nucleophilic substitution, followed by the cyanide reacting with a Grignard and getting hydrolyzed. So in this case, compound A would be an anti-MR peroxide effect, Kharab effect. And then the corresponding cyanide, and compound B would react with PHMGBr, where this would get, attached to phenyl and a double bond group. So that's option A, I believe. That's option A, I believe. Option A looks all right. 42. Number of structural C5H12O which react with PHMGBr to give you benzene. So what's the common answer for question 42? Number of structural C5H12O. Naturally, this would respond to a CnH2n plus 2O, which is the general formula of alcohol. Number of structural CnH2n plus 2O, which react with PHMGBr, to give benzene. Come on, tell me. हाँ, मैं बताता हूँ इसमें क्या करना है. इसमें 5 कार्बन का अल्कोहल बनाना है. 5 कार्बन का अल्कोहल बनाने के लिए हम लोग सारा अल्कोहल नहीं बनाते. ये मैं क्लास 11 में बताता था कि सिर्फ 3 स्केलेटन बनाते हैं. और देखते कहां पर हम लोग OH लगा सकते हैं. 1 2 3 2 1. 4 and 4 would mean OH यहाँ पर है, यहाँ पर would be the same compound. 5 6 7 8 8, and there will be 8 alcohols. I think you were not drawing all the possible structures. Were you drawing all the possible structures? Now, big time, you remember these. I had done it with you in class 11. So you don't go after drawing all these structures. That would kill so much of time and would be so unnecessary. Yes or no? Just think about the possible alcohol with 5 carbon. 43 and 44 are questions which are obviously not involving Grignard. I would have written it just for the sake of it. So 43 is about this one heating and see if we could arrive at this product. This will be the final product. You understand me? First of all, I'll see this geminal dicarboxylic acid. I'll see geminal dicarboxylic acid. I guess you know a geminal dicarboxylic acid. A geminal dicarboxylic acid on heating loses carbon dioxide. So this is decarboxylation without fluorine. This is decarboxylation without fluorine. So a gem dicarboxylic acid, a beta keto acid, and a beta gamma unsaturated acid. I give you 3 basic cases where soda ion is not required. A geminal dicarboxylic acid, then a beta keto acid. A beta keto acid on heating would also lose carbon dioxide. You'll want to keep this in mind. What option is that in question 43? So that's option B. I guess you got it right. B, 43B. 44. 44 looks a little more complicated, but eventually it will again be a case of beta dicarboxylic, geminal dicarboxylic, which will lose 2 carbon dioxide. And yet again, I'll be tempted. To eventually get rid of these 2 as well, because they will be again cases of beta keto acids. See if you get this. What the option corresponding to this compound? Now, C would be not right. C would not be right. Because when you reach this far, see, there's a difference between this and this. You could have stopped here, and it can be as the right option. Here, you would want both of them to become enol. Because here, with 2OH, you'll make it aromatic, yes or no? Here, with 2OH, there's a possibility of making it aromatic. So small little things you'll want to understand. That in the previous case, maybe you stopped at the keto form. In this case, you'll want to go to the enol because enol is aromatic. So option A would look correct. Take a note of it. 45. 45 A. In 45, I want to start with. Sorry? In 45, I want to start with 3-methyl-3-hexanol. So this is 3-methyl-3-hexanol, I believe. And option A says CH3MgI plus 3-hexanol. Now this looks all right. Option B says C2H5MgI and 2-pentanone. So if I choose to draw 2-pentanone, if I choose to draw 2-pentanone in this way, I mean, this is only to give you a view which would look all right. C2H5 would come here. Yes or no? बच्चे लोग हाँ ना बोलो.
हाँ सर.
क्या करता है भाई? सब कुछ राइट करता है, यहाँ पे गड़बड़ कर देता है. ये भी सही लगता है. C3H7MgI plus 2-butanone. I'll choose to write 2-butanone in this way. And naturally, all of these would appear The correct answer. 46. 46. एक्वा ट्रैफिक सब दिया है, गेट यूज्ड टू दिस। ये CH3 माइनस कैसे होगा? ये नेगेटिव है ना, ये इसको लात मार के निकाल देगा। मैं बार बार बोलता हूँ, इसका आदत डालो, इसका आदत डालो। दिस इज अ गुड लीविंग ग्रुप। ये क्लोरीन इसीलिए दिया हुआ है यहाँ पे, ये क्लोरीन इसीलिए दिया हुआ है। Halides are very good leaving groups. There will be intramolecular nucleophilic attack. There will be intramolecular nucleophilic attack. To begin with, CH3 minus attacking that carbon is something you all know. With a carbonyl, there's no step in the attack of the nucleophile. So you'll want to begin with CH3 minus attacking, and that O minus would knock out Cl minus via intramolecular nucleophilic substitution to get a 5-membered ring. 1, 2, 3, 4, 5-membered ring. So draw a 5-membered ring. Draw a 5-membered ring, where say you have just methyl, and that's it. And obviously one more methyl coming in. Sorry, एक methyl यहाँ पे आएगा. Option D would look all right. बच्चे लोग हाँ ना बोलो.
हाँ सर.
47. 47. is C8H6 with palladium, barium sulfate, and hydrogen becoming C8H8. That with B2H6, H2O2 OH minus becoming X, and this with Hg2 plus H plus hydrolysis becoming C8H8O, which reacts with ETMGBr, and undergoes hydrolysis. Right. So first of all, C8H6, tell me what is the degree of unsaturation here? प्रथम तेरे को देरी हो तो निकल सकते हैं. C8H6, FB बस 5 मिनट में खत्म हो जाएगा. C8H6, what is the degree of unsaturation? Come on. C8H6 would have 18 hydrogen. Yes or no? So out of 18, 6 is there, 12 is missing, 6 plates are missing. Come on, you need to be more upbeat with this. And with C8H6, degree of unsaturation 6. Now this I would be having an aromatic ring for sure. 2 कार्बन और है, पैलेडियम बेरियम सल्फेट, ये तुम्हारा लिंडलर्स कैटलिस्ट है. तो लिंडलर्स would also give you an idea about presence of a triple bond becoming a double bond. Yes or no? So this would be C8H6, which will become C8H8, which will become C8H8. Using Grignard, it will become a double bond, and this with B2H6H22OH minus, which is hydrogen oxidation, would give you an anti-amar alcohol. So this is going to be compound X. Yes or no? अरे हाँ ना बोलो. इसका हाइड्रोलिसिस करोगे, इसका हाइड्रोलिसिस करोगे, इसका हाइड्रोलिसिस करोगे, तो मार्कोनिकोव विनाइल अल्कोहल जो बनता है, acid substantiums would become a ketone by tautomerism, and this ketone with ETMGBr is expected to give you this final product as Y. So X and Y being decoded, X I believe is option C, Calcutta in question 47, and Y in question 48. Y in question 48 is now यहाँ पर एक heat और दिया हुआ है, यहाँ पर एक heat भी दिया हुआ है. तो यहाँ पर you'll want to go one step ahead. यहाँ पर इसको डिहाइड्रेट कर दो, इसको यहाँ पे डिहाइड्रेट कर दो, इसको यहाँ पे डिहाइड्रेट कर दो, and naturally go for the more substituted alkene. This is the final product, the dehydration product of the alcohol which I had drawn, and I think option D is the right option for question 48. I think you are getting me right. बच्चे लोग हाँ ना बोलो.
हाँ.
Which part? No, tell me which reaction you are able to understand. If you want me to repeat the entire part, it means you need to read the question one more time. Read the question one more time. Degree of unsaturation is generally handy. Although, you know, from the very look of the sequence of reactions, you could predict C8H6 is a alkyne becoming an alkene because you're using a Lindblast. C8H6 with degree of unsaturation 6. Aromaticity would involve, and aromatic ring will involve degree of unsaturation 4. 1 ring and 3 pi bonds. So you're left with 2 pi bonds or 2 degree of unsaturation. You make it a triple bond. Now this is within reach. This is within reach. The only part involving Grignard is this particular reaction. क्या बोले बच्चा? मेरे को पता ही चल रहा aromatic होना चाहिए because otherwise it would be very messy. It would be extremely messy otherwise. With 6 carbon, degree of unsaturation 4 would be a very untypical kind of a compound which would never match with any options in any given exam. So with this much of unsaturation, you believe aromaticity is on. ठीक है? I tell you this is within reach. मैं अगर ये लास्ट पोर्शन हटा दूं ना, तो ये क्लास 11 है क्वेश्चन. बिकॉज 11 में तो मैं बता ही देता हूं, एल्काइन में हाइड्रोजन होने से, मार्कोनिकोव इनोल बनने से टोटमराइज करके हमेशा कीटोन बनता है. मेरे को लगता है तुम लोगों को काफी सारा काम देने का भी जरूरत है. एक काम तो है ही, घर पर तुम लोग फिनॉल अच्छे से पढ़ने लग जाओ, कंप्लीट ऑल ऑफ फिनॉल बिफोर यू मीट मी नेक्स्ट. और दूसरा काम मैं खोजता हूँ तुम लोग के लिए बहुत सारा. ठीक है? Forty-nine is a different kind of a problem. So now I think now you're understanding me. यहाँ तक समझ में आ रहा है. ये कीटोन बना लेगा, उसके बाद में ग्रिग्नार्ड ऐड कर दिया. ठीक है? I from the options I realized that I should have carried out a dehydration. ये dehydration would give you the more substituted alkene. 49. Anyone with the answer to 49? Who will tell me what's 49? Come on. So you have a compound like Br, CH2, C triple bond C, CH2, Br. अब 2 मोल मैग्नीशियम ईथर ये एक्सेस दे देगा, तो इसको भी MgBr बना लेगा, इसको भी MgBr बना लेगा, इसमें कोई प्रॉब्लम नहीं है. बच्चों लोग हाँ ना बोलो. But the real question is, what if you have one equivalent of MgBr or one equivalent magnesium? ठीक है? मतलब एक effectively एक मैग्नीशियम होगा तो क्या होगा? हाँ? देख, कहीं पर भी कोई भी मेटल अगर अपना मेटेलिक कैरेक्टर एग्जिबिट करेगा ना, तो सबसे पहले कोई भी मेटल क्या करेगा? वो इलेक्ट्रॉन देगा. यस और नो? अब ये जो इलेक्ट्रॉन दे रहा है, ये इलेक्ट्रॉन को तो यहां पर लेकर के आ. ठीक है? अब एक बार एक सिंगल इलेक्ट्रॉन हो गया, तो यू विल वांट टू कैरी आउट व्हाट्स कॉल्ड अ फ्री रेडिकल मैकेनिज्म. ऑलराइट? फिर इसको यहां पर लेकर के आ, एंड फाइनली an option like option D will look correct. An option like option D will look correct. ठीक है? इसका आंसर होगा CH2 डबल बॉन्ड C डबल बॉन्ड C डबल बॉन्ड C. ठीक है? दोनों ब्रोमीन would form MgBr2. दोनों ब्रोमीन would form MgBr2. Yes or no? दोनों ब्रोमीन विल फॉर्म MgBr2 और एक इलेक्ट्रॉन यहां से एक इलेक्ट्रॉन यहां से लेकर के दो पाई बॉन्ड बना देना, बीच में होमोलिटिक क्लीवेज कर देना। Fair enough? 50. And we come to the end of the problem sheet. Question 50. How many alkyl halide when converted to Grignard with ethanol will give 2-methyl butane. So it's like finding different Grignard and different halide forming the corresponding Grignard, which can give you 2-methyl butane. It's as good as finding the corresponding halide, which could be attached to the skeleton, which will be like 1, 1, 2, 3, 4 again. So answer 4, which is option C, what we call it. Fair enough? So with this, we come to the end of this set of questions. In all likelihood, I'll share some more questions on Grignard with you, which will not be typical MCQ-based questions. But this much of the time being, stay happy, stay healthy. See you guys. Goodbye. Mondo Kochi.
Yes, sir.